Chapter 2, Section 2 is about solving equations, and this is really the meat and potatoes of algebra. This is when you think of algebra, you think about I'm going to solve for x or I'm going to solve for a variable. And that is absolutely the main thing that we do in algebra. It's not always a super simple process, okay, but fundamentally the things we discuss in Chapter 2, Section 2 is like the framework for how we go about doing that. One thing we need to understand first is the concept of an equivalent equation. An equivalent equation is just equivalent equations are equations with the same solution. So if we look at these two equations, they are equivalent equations. 3x equals 21 and x equals 7. The reason that they're equivalent is because the same one value makes both of them true. So it's 7 here in this case. So I think you see that right away. 3 times 7 is equal to 21, and obviously 7 equals 7. Okay, so this is true. 21 equals 21, 7 equals 7. 7 makes both of these equations true. They are then equivalent equations. And that's, we're only dealing with the one. We're only dealing with the one variable here. Okay, so these are equivalent equations, and specifically this equation, x equals 7, is in a special form. It's called the variable equals number form. I don't know if that's the exact form of it, but it's in where all we have is a variable and a number. And a variable and it equals a number. There are no operations. It's just a statement of like 1 to 1, right? X equals 7. And the goal for algebra is to take an equation and get it into an equivalent equation that has this form of a variable equals a number. Because what we've done here is we've solved for x. We've said that x is equal to 7. If we plug that 7 back in here, well, look, it's true, right? So this is the goal. How do we go about achieving that goal? Well, what we do is we use something called inverse operations. Inverse operation is an operation that just undoes another operation, or it reverses the effect. So one example would be if we wanted to undo subtract 5, we would add 5. So addition and subtraction undo themselves. They are inverse operations. Multiplication undoes division. Multiplication and division are inverse operations. So if we think about that here, for example, if we want to get rid of this minus 2 on this equation, 3x minus 2 equals 4, we would say, let me rewrite it really quick, 3x minus 2 equals 4. If we added 2, well, that would now get rid of, we just have 3x, right? Okay, if we wanted to get rid of this 3 times x, well, then we would divide by 3, okay? So we could say like 3x divided by 3, that's just x. And the goal, remember, is to get x by itself, x equaling something, some number, right? So that's kind of the goal. But there's something very important to keep in mind when we think about these inverse operations. And that is that we always have to maintain a balance. Algebra itself, the word algebra, comes from an Arabic word that means balance. And what your teachers will always say, and what you always hear about algebra, is whatever you do to one side of an equation, you must do to the other. It's like if you had a scale and it was in an equilibrium, meaning one side of the scale was equal to the other, and your job was to maintain that equilibrium. Well, if you took something off of one side of the scale, you would have to take an equivalent amount from the other side of the scale, or else it would become unbalanced. And so that's something to always keep in mind when we do algebra, and we're solving for a variable, solving equations, is what you do to one side, you must do to the other. So let's do that here. And something to keep in mind also is that the order of operations is important here. Now, it is not always the case that you must absolutely follow the order of operations or you won't get the answer right, but it tends to be the case that you kind of work backwards through the order of operations and you'll have a better time working with better numbers. Let's see what I mean by that here. So this is the same problem from the previous slide. 3x minus 2 equals 4. Now, to solve for this equation, I'm going to apply inverse operations. So the first thing I'm going to do, let's do PEMDAS, right? PEMDAS. I'm gonna go this way through PEMDAS backwards. So if I've got minus 2 here, I'm gonna add 2 to both sides. Now there's two different ways teachers will show you how to do this. I'll show you both. Okay, well, plus 2, and now to maintain balance, we'll also have to add 2 to the right side. let's write now what that did for us. Okay, it gives us 3x, because minus 2 plus 2, there's no more 2 over there. There's no more constant. That equals 4 plus 2, which is 6. Okay, now look, we have 3 times x. We're trying to get it into the form of variable equals number. So x equals something. So in order, we got to get rid of this times 3. So to get rid of the times 3, we're going to divide by 3. And since we did that to the left side, we also have to do it to the right side. So that means x is equal to 2. 6 divided by 3 is 2. And boom, there we are. That's our simplified, that is our simplified equation, basically. It's an equivalent equation to our original one, and it's in the form of variable equals number. Okay, for this next problem, if we have two things happening here, or it's kind of depends how you think of this. You can think of that x is being multiplied by 7 and then divided by 2, or you could just say it's being multiplied by 7 halves. And so so what you can do here, totally reasonable, is to divide by 7 halves, because we're multiplying by 7 halves, we're dividing by 7 halves. But when we do to one side, we have to do to the other, so 7 halves. So what we then are dealing with is x is equal to 2 divided by 7 halves. Then you have to know how to deal with this. It's the same thing as 2 times 2 sevenths, which is equal to 4 sevenths. Okay, so 4 sevenths is 4 sevenths is what x equals here. So let me write that. X is equal to 4 sevenths. Okay, you could do this differently. I'm going to show that now here. You could also have just said, just erase all this. You could have also said, well, maybe if I rewrote this really quick, it was like 7x divided by 2. That's the same thing. So now we're like, oh, okay, I got to multiply this. I'm going to multiply by 2, and if I did that to the left, I have to do it to the right. So then I've got 7x equals 4, right? Because 2 divided by 2 here is equal to 1. And then I'm like, oh, now I got to get rid of that 7. So that means I have to divide by 7 because I have multiplication there, and I have to do it to both sides. So I'm left with x equals 4 sevenths. Okay. Either way, you get the same answer. Different approaches to the same problem. And just to show you the other and probably more common representation of how you do this, for this problem over here, what you will often see is a kind of vertical orientation when you do your algebraic operations or your inverse operations. Like for example, we can add 2 to both sides of this. Well, it's kind of too bright. Let me undo that. So add 2 to both sides. When we do that, sometimes you'll also see people put a line right here, and you just do your arithmetic down. So negative 2 plus 2 is 0, right? So 3x plus 0 now equals 4 plus 2, which is 6. So we're at this stage, 3x is equal to 6. And then we can just do the same thing where we divide both sides by 3, and we're left with x equals 2. So it's the same exact thing. It just looks different. It's really up to preference. Some teachers will be very strict about how they want you to do this. As long as you are able to keep things tabulated and make sense to you on your paper and make sense to somebody who's reading it, because you also are going to want to be able to help other people with this, or you're going to want to demonstrate to your teacher that you know what you're doing. As long as that is clear, it's fine. And then the last thing here is we're going to kind of do two things here. We're going to think of we're going to have to do these inverse operations, and we're also going to have to combine like terms, because we have x on both sides of this equation here. And that's kind of confusing, because if we just kind of go about this, it's gonna end up putting us in a weird place. So let's assume that we're just gonna do this kind of incorrectly first, and we're gonna add 2 to both sides. Okay, which is not incorrect, but we can add 2 to both sides, and we will be left with 3x plus 0 equals 4x plus 9. So we'll have 3x equals 4x plus 9. And then we're like, oh, okay, well, what do I do here? This x is being multiplied by 3. Do I divide everything by 3? So do I divide the left side by 3 and the right side by 3? What would happen if we did that? We'd have x is equal to 4/3 x plus 9 divided by 3, which is 3. Now, you can see that we're really not in a ton better shape than we were to begin with, because we still have x on both sides. And so what's required here is that we combine like terms. So you can also combine like terms within an equation. The only thing we have to do is get and this is often called get all the x terms on one side, or combine all the x's. So let's look at that. So this is valid, like you can do this, but it's kind of the first thing you should do is get all the x's together. Okay, so if we look at this, 3x minus 2 equals 4x plus 7. So what I'm going to do first here is I'm actually going to subtract the entire 3x from the left side of the equation. Okay, and then because I did it to the left side, I'm going to do it to the right side also. And notice how I kind of did this vertical alignment, and I kept the x's like on top of each other. So now if I take 3x away from the left side of the equation, I've just got negative 2 equals, and then 4x minus 3x is just a single x, and then plus 7. Okay, so now all we have to do is get, we want to have this in the form of a variable equals number. So really what I think I should do here is I just subtract 7 now from both sides. Okay, so if we subtract 7 from both sides, we will have negative 2 minus 7 on the left side is negative 9, okay, equals, and then just x. So boom, we're done. X is equal to negative 9. That's the solution to this equation, and it was where we had to combine the x's and we had to combine the constants and get them on opposite sides of the equation, so we had that final form of variable equals number. So you can do algebra. You can, as long as you follow these kind of rules. These rules, or whatever you do to one side, you have to do to the other. You'll get there in the end. But there's some strategy involved. There's some benefit to doing it in a certain order. That order doesn't always necessarily need to be followed. It just can help to simplify the process overall. And honestly, this process here is probably the most important thing to your success in math. Is can you solve for x? Can you use these basic algebraic rules, these inverse operations, in a strategic way to solve for x?